Hi, everybody. We have a panel here of notable portable stimulus experts. I will introduce each of them. First, I'm the moderator, representing the Portable Stimulus Working Group. Then we have Cristian Amitroaie from AMIQ, Matan from Cadence, Sandeep from Vayavya, Prabhat from AMD, Matthew from Mentor, and Adnan Hamid from Breker. So these guys have all, in one way or another, been involved in the Portable Stimulus Working Group, either as direct technical contributors for most of these guys, or kind of overseeing the adoption of portable stimulus in the industry through their work with their customers and whoever. So we're just going to have kind of an informal discussion here. There's no formal position statements from anybody or anything like that. We're just going to kind of keep it going. So I will get things started just to kind of set the context here for everybody. I'm going to go down and ask each of you, what is your favorite new feature that we've added in 1.1, and kind of what are you most excited about for portable stimulus going forward? All right, Adnan, you're up.
I think my favorite addition is that it has moved forward a lot, right? So I think we've really brought in a lot of capabilities that we need in the first place, functions, memories, registers, and so on, so that's good. I think the really big thing will be figuring out how now to apply these things practically to real-life problems, where we want managers to be able to understand things, engineers to be able to write things, and to reuse them on all these platforms. So I think there's a lot of exciting things to come from this.
Yeah, I think I'm most excited about some of the features for engineers, the things that make expressing complicated scenarios easier. Matan talked about the replicate operator earlier today that helps writing repetitive things, making that simpler. And there's a whole slew of these features. They'll probably be touched on later on, but that's the type of thing that excites me.
So I guess I'm most excited about the procedural interface that we defined. The thing is, whenever I talk in my company at AMD, well, we should work on portable stimulus. But, you have to rewrite your code for all the different environments. That's the first thing I get. It is portable? What is it? What are you talking about? So I know I'm very happy that now I can tell them, well, you really can write the code once and it'll be done. And obviously, after that sinks in, the second question is, well, we have a bunch of C++ complex libraries and system Verilog libraries. How do we use that? So at least I'm past that point where I don't have to defend the portable in portable stimulus. So I'm happy.
Great. Sandeep?
All right, Prabhat kind of stole my line. But yeah, favorite things in 1.1, procedural constructs, everything that allows you to make the realization portable. So, of course, things like memories, registers. I mean, those of who you've interacted with me probably know that that's something I strongly feel about. We've all worked hard as a group and happy to really see some of these things making their way in 1.1.
So I think when 1.0 came out, it was mostly laying down the groundwork, the fundamentals of the semantics, execution semantics, solving semantics, and it's, I believe, a fair, a solid basis. But when we went out to try and do practical things with it, we got stuck. Some of the most natural things that you want to express, you would have to kind of hard code, and you'd end up with maybe abstract, high level, but very directed test cases. And so I guess, like Matthew, I believe that we're now closing some of that gap, which I mentioned in my talk earlier. Some people came back to us saying, what were we thinking with 1.0, having got stuck so soon with some basic modes of expression? I think we're filling in that big gap. Of course, things that other people say, these are also key. So it's all good.
Okay. Cristian?
Yeah. I cannot say that there is something that really excites me, because all of the things that were added to the standard were really necessary. So some things that were missing, as Matan was saying, you could get stuck very easily. But I'm happy with the effort that's being put in the realization layer. That is true. So the procedural interface, all the register modeling, but also on the abstract side, on the modeling layer, the template types, as well as collections, they are a very important part. So it's not that you can be excited about these things, really, because they are pretty common sense in any decent programming language, honestly, right? So it's not like we are inventing rockets. The true challenge, though, in the standard is that it's not a language like any other language. So that's what raises a lot of debates whenever adding features, even on all this stuff. And there is a little excitement here on standardizing the procedural interface that, you know, it's like when you write a function and you use all sorts of operators and things like that, it's not that you are really saying something necessarily procedural in the traditional sense. So it has an impact on the generation, and so it's a bit more. But, okay, shortly, the realization and all the template things.
Okay, great. So feel free to jump up with questions at any time.
Just trying to be realistically cautious here. I think my question is for you, Prabhat. So as you were going through the phase of whether do I want to buy into this or not buy into this?
Oh, you definitely do.
Into PSS?
Yes, definitely.
Did you ever ask any of these guys the question, why create a new language? What is missing in one of these that we can't just pick up? You know, as engineers, we really like to say, oh, this one aspect I don't like, I'm going to create a new language. So tell me your thoughts about that.
This is one of those things where I hate being the moderator because I can't answer the question, but...
No, that's a good question. You know, working in Motorola in '96, I still remember people in Munich, Germany office talking about creating reusable tests, abstracting basically reads and write operations and somehow making it work at IP level as well as a embedded core system. So we've been trying for this kind of reusing test or writing test in a more abstract way for a long time. We come a long way with UVM and, constraints in UVM, but still, if you sit down, if you ask any of your SOC verification engineer or in a subsystem, write me a complex test, or even describe me a complex test. It's very hard for somebody to tell me this is one complex test I wrote. They'll say, well, I'll move data from here to there. Maybe I'll use this IP or do this other thing. But why can't they do that? It's very hard to even describe a test, let alone even write it, right? So because the test space that you're working with is so complex and you don't even understand that, it's almost impossible for a human to describe a really complex scenario to do whatever you want to do to test it. And that's why the more formalism that's coming now with PSS in terms of describing your test space in a more abstract way, and then adding a more procedural interface also on top of it, it gives a tool to be able to help you here. So that's why I think it's really important to have a new language for that, because any procedural language doesn't really cut it.
So what is missing, and not talking about the UVM, what is missing in System Verilog or System C that everything that we went through in the previous tutorial, that everything cannot be coded in that?
Right. So think about a subsystem with a DMA and a graphics engine and some other IPs, right? And you want to write a test that, I don't know, I'm trying to imagine a complex test here, right? You want to write a test that DMAs some data, starts DMA on one DMA IP, maybe you have two DMA controller. You want to, at the same time, maybe, or maybe after you use the same data, maybe that's an audio data, go to an audio processor and process it, put somewhere else, right? You're making it up, right? You're trying to write this procedurally. You're thinking in UVM, okay, my virtual sequence, I'm coding it up this way. This is, of your test space, different test scenarios, this is just one thing. There could be hundreds of combinations of this that you're not even thinking about when you're writing your subsystem test.
I'm a verification architect, so
Right, sure.
I definitely do think through all the use cases. How is the system going to be used? If there is a problem, how do I test at the block level? How will a scenario that's presented at the system level, how will it present itself at the block? And I should be able to test that at the block. So, a lot of us do think through those things. So if you architect your test bench and the test bench components and the objects and all of that properly, thinking through all of, all the use cases, what would I not be able to do in System Verilog that?
Okay.
I'm going to use an
Matthew, you're gonna
analogy,
jump in, go
okay?
ahead.
You talk about thinking through all of these scenarios, and that's really important. Let's go back to the early 80s. When I did this with...
Should I go back?
No, you might have a
Question
follow-up.
stay.
So think back to the early 80s. We did financial analysis in spreadsheets, which were a piece of paper. Software came along to allow us to do that analysis automatically, or automate a lot of that. So we didn't have to mentally think through the scenarios. We could model what the problem space was, do some what-if analysis. This is the same type of model-driven test development that PSS enables. It's a level up from what you can do in System Verilog, which has model-driven data generation, but not test capture.
I see.
So let me
To
respond
me, that is one of the biggest things with PSS, up-leveling in terms of what you can capture in terms of a scenario space.
The question on the table, though, was why do we need a new language?
Yeah, I was going to come back to that again.
So first of all, I think Prabhat brought up the key point, right, that we need high levels of abstraction. You brought up the key point that, hey, I'm a verification architect. I know what needs done. And I'm going to tie this all up to something that Matan said this morning. Okay, you're a verification architect. You sit with your team. Each of you sit in rooms. You go on a whiteboard and you start drawing what you're trying to do, right? You're drawing flow charts. You're drawing data flow charts, control flow charts. And that's how we explain to each other what we want to do. Well, at its basis, all PSS is about is being able to capture those flow charts, right? Matan was talking about is based on UML activity diagrams. What do they do? Control flow and data flow. Now, you're also correct that we are used to programming in certain ways, right? And the adoption of this will be how familiar it is, right? And I think, when I said that I'm excited about all the things that came into 1.1, it is about bringing, everybody was talking about these procedural things, right? Basically, we've added functions into this language. Now we can code procedurally. So, yes, it is coming closer and closer to a full-fledged language, and that's what you want, and that's what makes it easy to adopt, okay? So what I'm trying to say is, yes, it is coming as a regular language.
Adnan, the question for Adnan and whoever can answer. Hate to be on the same topic again, but I understand in a big picture, like the flowchart, UML modeling, and turning into another language, right? But the for all, it looks very similar to for each, right? Yes, for each is iterating on an array, but for all is actually more higher abstraction level, right? But I want to go back to the system Verilog language itself, right? There is cover point and there is SVA cover, right?
Yeah.
Both are similar. And cover group, right?
Yeah.
And you go to the constraints, right? There is constraints that can be captured in the classes, but you could actually write formal constraints in the form of assertions, right?
Mm-hmm.
But they're not portable, right? I mean, you write one, you have to literally somebody actually translate it to another form, right? So now the question I'm asking is, when you're coining a new construct, can you avoid doing that? Can I actually probably, like a for each can be made into a, enhanced to a higher level so that it can be used in both places, right? Instead of just, coining another construct, that's actually confusing, right? I'm just trying to learn what are your thoughts when you're actually creating this language. That's my question.
We spend a lot of time with exactly that type of argument. Can we cover those with a for each? Is that more confusing or less confusing than having a new construct, given that the semantics are quite different? In that case, we decided it was less confusing to have two dedicated constructs because the application was different. But yeah, we spend a lot of time arguing about exactly that type of thing in the committee to decide which presents the semantics most clearly to the users.
Okay.
By the way, I will point out that if you want to get involved in those kinds of discussions, you can join the working group. Go ahead.
Right.
But on the other hand, you should be aware that in the working groups, there is always a debate whenever we want to add something new. Yep. Nobody wants to work, right? So whenever somebody comes with the idea of doing, something on collection types like Matan near me, yeah? But he deviates from reusing templates or whatever to solve that and introduces some little new language extensions, you'll be sure that the others will say, and there are many times fights, so it's the standard is pretty conservative with respect to adding all sorts of things. Sometimes some decisions taken in the early stages, like this replicate, for example, were really a bit unfortunate, like semantic-wise. Like we have repeat, and then you have replicate, and maybe you should have a terminate, or I don't know what. And then we ended up with some things that occasionally look a bit artificial. This is true, but it's not because of a greediness in... Believe me, you know, whenever we have to do something new, there is a reluctance because somebody needs to write the spec, debate the spec, convince the others about it. So there is work. And as engineers, we always try to,
Don't get him wrong. I'm the guy who doesn't want to work.
And Viva, I will say that I actually come from your school of thought, right? As why should we have any new constructs? And I think there are trade-offs to understand over here, right? On the one hand, we should just stay with the constructs we know. On the other hand, we are trying to build a certain level of formalism into this language lingo so that tools can deal with it. And that trade-off is not simple.
Right? Yeah. So for the problem case I mentioned, like the constraints, in system Verilog classes versus assertions, and it's a problem. It's a different topic, but I just want to leave it there. Can Accellera or the group can actually help on actually merging all of this to write in one form of constraints, right? Just a question.
So if you buy me a beer later, I will tell you the whole system Verilog story. How's that?
I'm sure I would enjoy that. Thank you.
And you're going to volunteer to fix this problem?
Any other questions?
I want to make a comment about this language question, which comes up a lot. And I think somehow people get hung up on the language, on new syntax. While that's a concern, I don't think that's the main gap in adoption. The problem that we created is this new set of concepts and the paradigm shift that is involved in what Matthew called a model-driven approach. And not only could we have done it in C++, we have done it in C++, and not only could we have done it in some clunky way in system Verilog, some people have. The question is how to encode a different paradigm that other speakers refer to as being a more formal, declarative capture of a scenario space as such. And ultimately, that would be an easier way to express what is currently very hard, actually, in system Verilog, in low-level constraints very often. So when you're trying to capture the configuration space, let's say, of a non-trivial IP today in system Verilog, you're making some major compromises, right? Because either you're going for something very directed, like point cases, or you're taking on some broader capture of the space. And then you're really operating at a assembly level constraint language. You only have variables and algebraic constraints, and you need to encode all of the complex dependencies with respect to resources, with respect to states, with respect to, possible. So this is what you must have heard the term ordering a sparse space of configuration. It's not just a matter of there's so many registers and they can take on any value. It's not like exercising a hardware protocol where it's essentially a data modeling problem. Here we are talking about the operations of complex IPs, subsystems, a full system. It's about behaviors, how they interact, how they depend on one another. When you try to do all that in this assembly level constraint language or modeling language, system Verilog, you're going to spend a lot of effort putting this together, debugging the contradictions, trying to close on the coverage. So ultimately, I think, forget the language. Again, you can pick up the C++ flavor of it, or a guy from AMD last year presented a system Verilog flavor of it. That doesn't matter at all. The question is, are these concepts working for you? Are they good abstractions, better abstractions for your complex scenario space? And if they are, then you're in a different ballgame in terms of being productive and hitting corner cases and converging on coverage.
Great. Thanks, Matan. Okay, question?
This might be a little bit loaded question, but has the committee considered about hardware encryption and modeling of a hardware encryption? Because here your data in the memory model would be totally different from what you've written out because it goes through the encryption process and it changes. Now, here your test space could be really different just because of the encryption and different. The encrypted data could go through different layers of encryption, different authentication. So, what's your thought about hardware encryption with PSS?
So,
Who wants to take that?
let me start at least. One thing that PSS does very well is model data flows. Okay, so you have these producers that feed these consumers. And we're not talking about encrypting PSS models, which might come up, but that's not the conversation we're on, right? We're talking about testing encrypted systems. So I think you can profitably model these encrypted systems or ECCs, these similar but different problems, right? Where PSS is set up to be able to call external routines, for example, to compute what the expected encryption data should be and so on. So I do think it gives you a very nice way of modeling your different encryption layers, how the data goes through your system, knowing where they're going to transfer, assuming, of course, that we can predict how to encrypt things, how to decrypt things. And it actually works out pretty well.
So you think the PSS tools will have functions to call how to predict the data? I mean, because like their standards, NIST has standards,
So
and
libraries will evolve, but really, okay, I'm not certain that I've ever met two people who actually use the same encryption algorithm.
Right.
So the languages, it's less about that than being able to call the functions you already have, right? Maybe they're in MATLAB, maybe they're in C, maybe they are in Verilog, who cares? What I'm after is that the modeling scope is there, the modeling power is there. And at that point, it's reduced simply to, I know what data I have. I'm going to feed an array of bytes to some function that's going to give me back what the encrypted or decrypted answer should be based on whichever one you're doing, right?
So for you, I have actually two questions, right? Number one is, if you had to do this manually writing that test, how would you do that? So second question is, does PSS 1.1 or 1.0 does not have constructs to model your test space, which is, I have IPs that can take some data, maybe it's encrypted and it can operate on it, and maybe it can produce more encrypted data. Does PSS have construct to model that more formally or not? So you can go on the first one.
well, I mean, the thing is,
Did you just answer a question with a question?
With two, and I have
He
answers
multiplied
to
it.
the PSS has, I mean, this is the first time I'm introduced to PSS, so I'm just learning as through the tutorials, but has the functions to generate the data, whatever constraints you put in. But as the data flows through the hardware, it could go through different level of encryption authentication and ultimately ends up in memory. And then as a verification to read the data and see that did it create the correct encryption through this data flow is having function that Adnan mentioned, that do you have call the right function at the right time to verify that the data flow through there has been correct. So if I were to use PSS and then to verify my hardware, I would still have to resort to block level or small functions called within and just use PSS to just create the data. It doesn't give me an extra functionality that I could do with my, like constrained random testing through EVM.
No,
Actually, it does. So in your manual test, you'll probably already have libraries for different IPs in your data flow to encrypt and decrypt things.
Not necessarily. I mean, sometimes we have to develop them,
I mean, you have to write that to be able to test it, right? Anyway.
Right.
So you can model that data flow in PSS in a more formal way, right? There is an IP that takes an input data that's encrypted in this particular way. Mm-hmm. So you have a test component in PSS, right? That's kind of representing that in one IP. What you're talking about, you're saying, this is my IP, take this data, this is the format, this is the encryption, and this is all the data that you can model about that IP in terms of what it takes as input, what it produces as an output, right? Mm-hmm. Now, this is in isolation. Imagine now you put together a PSS system with a bunch of those that you created separately, and with PSS formal mechanism of input, output, and describing dependencies between things. As a test writer, you could just say, give me a test that creates an output from this IP, maybe third IP, right? PSS tool might create you 10 tests that will produce a valid legal data flow for you with feeding all the inputs and build up a test or 10 tests for you. So that's the advantage that you're getting, when you're creating the test, once you have the library in isolation for all the components, and you describe their properties, input, outputs, and resource dependency, you can get hundreds of tests that you could not write manually. And obviously, the actual encryption code with the procedural level thing that we coming in PSS1, you could write in PSS code itself that can be retargeted by tool to your C environment or UVM. So that's an extra advantage on top of the modeling capabilities the language provides.
I don't imagine serious encryption algorithms, a reference model coded in PSS, right? And I think you typically have them in some other format. If you had a reference model in C++ or MATLAB or something, PSS is not made for that, right? But the beauty is, like Adnan said, you can easily bind to whichever assets that you have, in particular reference models, algorithmic, heavy algorithmic code. And like Prabhat said, the beauty is that now you can easily plug this into higher levels, test cases, and it would be just a plug and play thing. A checking part is also generally part of your model that you have in action that kind of checks the.
Yeah, I understood that. I would like to take the advantage of PSS to, like you mentioned, that scenarios that I wanted to create and generate hundreds of tests that I don't have to really think through.
So I'm just going to put a plug in for myself. There was a paper last year at DVCon about error checking in PSS that you might find valuable. We can talk later.
Okay, thank you.
Anybody else?
I'll start with just a quick one on the naming. So there's a spec here describing a language. I don't know if PSS, DSL necessarily rolls off the tongue. So I'm just curious, what would engineers say they're doing? Are they writing PSS code to describe a PSS model, or what's the language here for the language?
I think the answer is yes.
Okay.
Though I agree with your concern.
Okay.
Now, this is a good question about terminology. What is a PSS model? What is a scenario? What is the test?
Yeah.
And I guess we need to do a better job in defining this.
Okay, yeah, I interpret more as a standard, but there's the language, and do we just put it all under one umbrella? Sounds like that's kind of the default. Okay. Second question I had is more on the randomization side. Is the intent that all randomization is done at test generation? Or are there any leftover bits where, say, your source language, whether it's System Verilog or C, would do some minor sort of randomization, say for data values or anything like that? Or is it all meant test generation truly gives you a focus test to do one thing for that specific run?
You do have to think about, testing is a multi-level thing. The question came up earlier to Tom, does PSS replace UVM? And the answer is, well, no, because there are kind of structural aspects to UVM. There's a lot of infrastructure there that PSS kind of fits on top of. Sure. That infrastructure might involve randomization as well, lower level randomization, stuff that is not necessarily attached to the high level scenario. So I think it certainly makes sense to delegate some of that randomization lower in the chain. Depending on the platform, it might happen in UVM. When you go to embedded software, there might not be any randomization. You get value at the appropriate platform.
Okay, makes sense.
From PSS, you generally control the data and the control flow, but anything that changes timing, you can leave that to the UVM test bench because the checking doesn't change. Right.
I want to add to that, and I think both Matthew and Adnan referred to the important point of maybe delegating some of the randomization and generally some of the decisions to the underlying layers, right? When you layer a PSS model on top of a UVM environment, or maybe a system C, or even a substantial C, embedded C layer, there could be randomization and a lot of smartness, not just randomization, in these layers that you're not taking over, right? Because that's not a critical part of your intent. That's one answer to your question. There's another answer that is PSS itself is built in a way that the behaviors are described without commitment to when decisions are made. So let me give you an example. When you use the repeat statement, that just looks like a regular loop, right? But a repeat can be bounded or unbounded, and the termination condition of the loop could very well be some runtime condition that's not known up front. Imagine you had a select inside that repeat. either A or B. How many times do you need to do this selection? You don't even know at generation time. So if you read the standard, the semantics of these constructs saying what you expect, that a repeat would do it these number of times, and a select would randomly select a branch every time. Is it happening in a pre-generation flow? Are these decisions taken upfront or deferred to runtime? That may vary, and that's the beauty. And that's the case, I think, with many other constructs, that there's a lot of room for us to innovate, to strike the right balance between offloading some of the decisions and leaving some of the variability in the generated test.
Yeah, but on the other hand, Matan says that's the beauty, but that's also a trap from our experience with users. So whenever you read a standard that leaves some things beautifully creative, yeah, you get awful interpretations, and I think there is some work to be done at that level in the standard, right? Because even this simple example with repeat being a gen time versus runtime, so it's a debate, and even inside, I believe even here, if we sit at the table, we won't agree necessarily on what exactly it means. So you jump to answer, but you open a...
That's the beauty.
I agree with you.
No,
at least we all agree that the flexibility is important. Right. Yes.
Matthew, you want to say something?
No, I was just going to say, at this point in the standard, probably flexibility is more important over time. It may be that we need to codify some of these things according to the platform, according to something else. At this point, I think flexibility is more important.
Okay.
So we're working through a fairly complex model, and we're doing it in UVM, and resorted to creating helper objects in the environment that the tests could inquire about the details of multiple DUTs that are all packet encryptors. Something complex like that with control ports and data flows through multiple paths. We're finding that a lot of our tests are directed just to cover the functionality that's essential to deal with requirements, and only a limited amount of randomization, mostly packet sizes, kind of directed sequences. I'm really excited about what I see in PSS in terms of being able to apply a lot more randomness into the construct. But I'm wondering about the business case. I mean, if you were doing something like what my team is currently doing in UVM with workarounds, you end up with constrained time and money doing a subset of the verification. It sounds like the PSS would increase the number of cases at maybe half the cost, and that's the question. In your experience, you're an experienced UVM panel, and you're an experienced PSS panel. When you take PSS and you're targeting UVM and ignoring the portability of going to the C-level accelerator, if you would, where the test cases are done on the hardware with a driver, so to speak, what kind of benefit are you seeing in terms of coverage improvement versus effort, or reduction of effort for similar coverage? What's the business case, right? You can see there's an advantage. It's obvious.
Right.
But in your experience, how much better is PSS with UVM over something we're probably in the middle of doing?
Okay. Who wants to jump in on that?
So we have some data on this, okay? And first of all, you characterized the business case dimensions correctly, right? Reduce work, increase coverage, and make it portable. Right? Whatever you're doing, you're always somebody else's units, right? You always have to fit into something bigger. Maybe the bigger thing is the internet, but eventually you have to fit into something bigger. We've seen savings in the order of, okay, there's some learning curve, right? So let's accept that. But we're seeing effort come down to maybe 20%, with coverage going up maybe 10x, 1,000x. If you already have randomization, it's hard to say, I'm going to do PSS randomization instead of what I'm doing. So my general story is, how many test cases do you have? If you have 100 and you're happy, PSS is not for you. If you have 2,000, that says you're probably content limited. And PSS answers exactly the kind of problems that you're talking about with, when you're screwing around, pardon my language, with all these side objects and handwritten tests, it means UVMs run out of gas for you. You need more abstraction.
I agree with everything Adnan said, and it's a little hard, as always, to come up with hard data on productivity, right? And,
Agreed.
And we all have
Will they tell you when they...
some kind of a metrics, and we like to do this analysis, but ultimately with our users, it's sadly a call of some different level that determines the decision. The problem in many cases, in particular when you're trying to do complex stuff in UVM, is that you randomize things because it's easy, not because it's some of the fundamental or important dimensions of your space, right? And then generally you do what's easy, and I think in retrospect you have picked up PSS and have been successful with, you realize that you compromised quality very much. And
recognize that, yes.
You know, we try to put numbers, 20% increase or 10x increase in this or that. I think these are valid attempts to quantify. But the best feedback that we get is, hey, we are now able to generate scenarios that we never even imagined that we would or we could. And we are now thinking of this in a much more systematic way and being able to communicate it and to reason about it. And really, we have the right cognitive tool to approach the problem. How do you quantify that? That's a little hard, but I think from your question, I can tell that you have a very good intuition about where the value lies.
All right, great. So we have time for one last question.
Hi. So amongst all our groups at our company, I kind of see we have all of the realization pieces already there. What I'm struggling to see is sort of a roadmap to this adoption that we sort of talk about. In your practical experience, do you go top down? So start with a C, we have all the C pieces and kind of start there and push it down into simulation, or do you start bottom up, go take from simulation and push it up? So what have you guys seen, and what works and what doesn't work, sort of advice, gotchas, that sort of stuff. Thank you.
Now you're going to really hear different things.
Yeah, all right. So
Different
really
opinions.
short answer from everybody on the panel, and then we'll wrap it up. Okay?
I'll start. At AMD, we found it was easier for us to start from the top, like SoC level, and then maybe go down, because a lot of time our IP teams are pretty well equipped with whatever UVM test benches or System C test benches and have pretty comprehensive tests. And that's not always the case with the SoC level or post-silicon. So we found the value where if you could start at the SoC level and create PSS model there, and to be able to generate some of the complex scenarios that I talked about, which is very hard to even imagine, at least for me, that's where the value is.
Great. Thanks, Prabhat. Next.
I think the answer is not about PSS or methodologies, it's about your project. I work with some projects where they're going bottom up. The big problem is at the IP level, they can't generate enough sequences and they want to reuse them going up. Other folks are trying to push top down because their story is, hey, the Yahoo's doing, excuse my language again, but the Yahoo's doing IP verification, have no idea what the system's going to do to their IPs, so I want to push these top-level scenarios down. So the answer isn't a question on PSS, it's a question on your flows, methodologies, your risks.
Sandeep?
So I'll probably try to answer this question more from the realization perspective or the HSI perspective. So we've worked with teams where, it's the SoC level guys who say, hey, I really want to reuse what the IP guys are doing, but I don't understand what they are doing. I don't get a valid sequence from them. So can you first get them to come out of their UVM world and provide me a sequence that I can understand? I don't want to read UVM or system very long. So, in our cases, we've seen that somebody from the top makes a push, but then we really work with the block level guys to kind of then go bottom up.
Great. Matan?
So I think, like Adnan Sandeep said, it's really a matter of the project, and practically you're going to start off with the main pain points for you. And that's why we, in reality, see people all over the place, and that's part of our headache, because the applications are starting from so many different... The vision is common, but the starting point varies so greatly that it's really mind-boggling. But I think the beauty of PSS is that, forgive me, UVM is kind of inherently bottom-up approach. And with PSS, you may start from the bottom, you may start from the top, you may start from the middle. It's not an inherently bottom-up approach. That's the key in PSS. So just like Prabhat said, pain point, for your project is post-silicon validation for the most complex power scenarios. It would take you a long time to get to Sandeep's IP-level programming sequences. You don't need to wait for that. On the contrary, you can start at the very top, or they say real systems have no top, but you can start from your pain point and then gradually refine down as you go, or gradually build up as you go.
Okay, thanks. Cristian? Matthew, I skipped you, sorry.
Yes. I was going to say, hang on, Tom.
No, actually, I was saving the best for last.
No, I certainly agree with Adnan's point that, in a way, PSS gives you the flexibility to, based on your project, decide what the right approach is. So it's very important to have a strategy when you approach PSS adoption. There's not one size fits all. Frankly, with my customers, I'm seeing a lot of benefit going from bottom up, getting automation, productivity benefits from that model-driven test creation at the block and subsystem level and pushing reuse up. But it's not a one-size-fits-all. You have to figure out for your own company where the value is.
Hey, but the main point is there's a lot of value. All right. Great. Well, thank you very much, everybody.